Greetings, my name is Brennan Gursey, and in this video I'm going to go over the second 2 weeks of development for my very own project Clockwork. Before we get this video started, I'm going to go try doing something a little different in this video where I just kind of go through some gameplay and some kind of light overview explanations without showing any code first. That way I can kind of keep these videos a little bit shorter so that way they don't drag on too long. It'll also help me out with kind of demonstrating my code and what it does. So without further ado, let's get started. So one of the first things that I've been working on here is just some general improvements to some of the smaller bits, such as UI. So for example, I now have a green highlight over the buttons in a lot of my menus. So give the players some feedback, and things such as that. Also added a little bit of a controller support too for these menus as well. So next thing I kind of been working on, as you may have noticed, I've been kind of walking around in this yellow square just blinking on and off. It seems to be based on distance. Well, this is actually one of the second things I've been working on. So I've been working on kind of a lock-on system to where the player will be able to lock on to a specific object or enemy. Depends on what necessarily the lock-on component is attached to. So as you can see, generally once I hit my lock-on button, the object will turn blue, and as it kind of rotates around, it kind of keeps it more centered. So it basically just keeps the object always in the player's view, and then once I tap the button again, releases it. It turns back to gray. That's for an entirely separate reason, but basically once I hit the button again, I now have free control of my camera again. So on to my next bit. So I began working on the time powers for this game. So time powers are basically some of the player mechanics that the player will be able to use to traverse and explore the world, as well as also do some general combat things and kind of manipulate the environment. There's 7 total between acceleration of time, time water, time warp, time barrier, time mold, time repair, time stasis. These names are temporary. I'm most likely going to change them. I do have the menu up and running. As of right now, I only have currently Time Warp prototype for it up and running. But the good thing about this menu is that even without them, the powers themselves being up and running, I have already worked in some logic to, once I get some more permanent UI assets in here, I can, but I'm able to swap out the small circles here on the left. As you can see, they're not only filled with an appropriate word for the power, but I can also kind of change between them as I go. So that's kind of nice. So yeah. So what I can do is I don't need to be locked onto my character to an object in order to do this. I can do it either or. But I'll demonstrate both. So if I hit time warp, what basically happens is my character will lerp in the air towards a designated spot. Notice that I did not actually go to the square itself, I went past it. That is because I actually have a separate vector location to where the player will be able to will be warped to. What I'm trying to make is something kind of a bit of fusion between I'll probably have some footage up here to show it. Final Fantasy XV's Warp Strike, done by the main character Noctis, and something a bit similar to also Kingdom Hearts 3's Shotlock. I think it's Shock Step? Yeah. So I can do this either locked on or not. There's, while I'm not locked on, step back a little bit, lock on, oop, same thing. Automatically locks me off, so that's pretty good. It will, however, kind of face you towards the object that you were on if you do the locked on version. So as you can see here, some other new UI element is I have this little blue bar down here that is my essentially my quantum energy meter. Kind of acts like mana in a sense that you require this in order to use any of the time powers listed here. So next thing is this little cloud right in front of me. I've mostly just been going for functionality. I'll create my own particle effect for it later. But this is kind of my quantum energy restoration. Basically what it does is basically when you step in here, it does activate a little bit of a visual. Kind of coats them in a blue kind of skin, kind of like what happens when you do the warp effect here. Coats you in a nice little orange. I like to call it my glow stick slash Dr. Manhattan. But yeah, so as long as you're still getting your mana restored, it generally uh, keeps you in that blue skin. So that's a couple of the things I've been working on. I'm gonna kind of move over here to my more interactive, sub-level sequence here to kind of show off a couple things. So one of the things that I did end up working on was that I made a parent class for my two platforming objects shown here that were in the last video. I kind of reskinned them, that way I can tell the difference between them. Um, I'll get a little bit more into that when we get to the coding section, but it didn't take too long to actually do, but it's useful for multiple reasons. Suppress aim. So these are a new platforming piece that I wanted to make, kind of like a rotating fan-ish type platform. As you can see here, it's able to spin at very high speeds, and then can also be spun at low speeds as well, so it's kind of nice. Something else here, kind of. Go ahead and just do some quick hop across. Yay. You also find some various tools and interactable objects from my previous video as well. This is the nice colored switch here. Notice that in difference from the last video, there was not an object that was immediately, there wasn't an immediate camera pan and then an object moved. That is because something I did not show off last time is that you can have multiple switches for the sequence. So that's kind of nice. Second one is up top over here. And you may be wondering why I have this weird, swirly, gnarly, metal-ish line over here. Rail? That is because this is actually a grindable rail. When my player lands on top of it, they will be grinding across the line from beginning to end. Yeah. This is something that I kind of had before from back when I was working on making my making some individual player mechanics before I really started working on making this project itself, kind of getting a little more accustomed to C++ and Unreal. But I have made a few tweaks from it. Most notably is that I'm able to actually adjust time, the time spent grinding, which I'll show you up here in a minute once I finish this out. So, so I'm going to kind of demonstrate kind of one of the practicalities that I would like to use in this game, especially with the time warp ability itself. I'd like to kind of do some mid-air maneuvering to where if I see multiple of these in a row, I'm able to go across them in order to reach a faraway platform that I would not be able to reach using standard my standard player mechanics. So kind of give like a quick tap for this. So 1, 2, 3, and as you can see, I've now gone from that back platform back there next to the cylinder all the way over here just by simply using my time warp power. So yeah. So last thing I kind of want to show off in my interactive level piece is I wanted to kind of make something interesting for when the player completes the level, kind of something similar to the Sonic the Hedgehog series or something like that when they reach an appropriate, emblem gold ring at the end. What'll happen is they will be greeted with kind of an animated scoreboard to kind of show the progress of what they've done throughout the level. Obviously, I didn't go through, if you were here from my last video, I didn't go through collecting any ability shards or fragments. I've just fed this fake data for the time being just to kind of show off the animation. But as you could see there, what happened was the bars and the different categories for these kind of came on screen, and then I was able to fill 2 progress bars, show the time completed, that is minutes and seconds. I should probably add something to indicate that. And so with that kind of brings me to the end of the interactive portion, and now I'll kind of quickly go through here and kind of demonstrate my code, both in my blueprints, my C++, and a little bit of the visuals that I've done for this. Alright, let's get started. So for this first bit for explaining the code, I'm going to go ahead and go through my C++, as I feel like that would probably be a little bit faster. Um, as a lot of my C++ that I've worked on this week is kind of all tied together. So without further ado, let's go ahead and get started with that. So for one of the first things that I did was that from my previous 2 weeks, I went back and I made a parent class for a lot of my manipulatable platform objects. Specifically the manipulable object class. So what this actually allows me to do is this allows me to it allows for me to make use of inheritance. And for those of you that are not programmers and are like, well, what is inheritance and why is that important? Basically, think of it like this. With inheritance, when it comes to classes in really any programming language, what inheritance allows you to do is you can create what is called a parent class. You can load it up with all sorts of functionality and variables, and what you can do is you can make a child of that parent class. And with inheritance, the reason this is useful is because the child inherits the functionality and variables of the parent. But the neat thing is that when it comes to changing aspects of those variables and functionality, you can change the functionality variables of the child without it affecting the parent. So it's essentially a way of having two very similar classes, but they have the capability of performing different functions. And that's actually why I created this object class here. So one of the things that I did was that I created kind of some shareable functionality and variables. So what I did was I created a timer handle, a float variable, which was the lerp alpha. We'll get to why that's important when I explain the children. And then we've created two functions, interaction command and move. So the neat thing about this is that I'm able to define my own different methods for the interaction command. As you may have noticed when I go back into here, if you remember from my last video, I had one of these little white panels over here that when I walked up to it, pressed A, it did something. In last video's case, it brought some of the bounce pads from a lower plane. It brought it in level with the platform that the player was standing on. Whereas with this, I press A and now the fans have stopped spinning crazy fast, and now they're going spinning at a much slower pace. This is the work of inheritance that I've been using on this. So the neat thing is that with my... Where is it? Here we go. So with my interactable class, which I use currently right now as just a panel of interaction, so the neat difference from last time is that instead of having to use an actor of a specific type, which last time was my bounce pad, I can now cast it to simply actors of influence, which could be of any class, so long as it has the appropriate method known as interaction command. So in reality, the actors to influence could be any type of actor itself. The neat thing is that by casting it to the parent class manipulatable object, what I'm able to do is any object that can be cast to this, I can call its unique interaction command. The unique thing about this is the fact that I can have two entirely separate methods for interaction command go off at the same time, just by simply casting my two different actor types to their parent class. So in the case of these two options, what happens is when I use the interaction command here, it'll lerp my bounce pad from one location to a new location using the general fmath lerp command in order to change its current location. Whereas with my large spinning object, when I hit interaction command, it just simply changes the amount to rotate to a slowed rotation amount. That's why you saw whenever it would go, it went from really fast to very slow almost instantaneously, is because this interaction command changes speed, while this interaction command actually moves an object. So that's very useful to me because it means that I can use many different types of interaction commands and string them together all under one control panel. So that's one of the main reasons why I decided to do all that. Um, Part of what you can see here is that I've done that for both of my object type, or both my previous platforms. So both my new bounce pad and my standard platform also are now children of the manipulatable object class. So that's really neat. The next class I'm going to go ahead and talk about is my lock-on actor class over here. So basically for my lock-on actor class, what I essentially do is I use a mixture of both C++ and blueprints in order to get all of the full functionality. For the C++ side of things, I kind of just use this in order to get a calculable distance to tell whether the block should be warpable, so to speak, or is capable of being locked on as well. And so what I do is I basically get my two locations. I do some factor math in which I find the difference between those two locations, and then what I do next is I find the magnitude of all this for here to get my true distance regardless of like X, Y, and Z orientation between the two objects. And then what I do is I normalize this to a range. And so what that allows me to do is it allows me to, if I go over here, click on my object over here, eject, and click on my actor. There we go. So what this allows me to do is this allows me to set a range in Unreal's vector units. And so what I can do is I can tell it to where if it's within a closeness between a range of 0 to 1, it'll change to yellow. Whereas if they're too close, say for example here, like clearly I'm at a good range to where I'm far away enough from it, but not too far out of range. So now it says that it's capable of being locked on. However, if I get too close, the lock-on goes off. I will most likely make two variations of this, because I plan on using this lock-on for enemies as well, not just objects. This was just a nice quick prototype to see what work would be necessary in order to do it. So this is where I generally check to see whether or not the normalized distance is within range of closeness, or if it needs to be turned off as far as the visual goes. I have two methods, lock on and lock off. These are very basic methods that are used in here. So what it basically does is I just basically take my dynamic material instance here, and I basically just set the vector parameter value, which in this case just represents color. So it changes from yellow to white for lock off. And then for indicating the actual full lock-on mechanism, I turn it blue. And then for the reverse effect, I just go back to the regular standard yellow. So that pretty much covers my lock-on and lock-off for my objects. Let's move on to the next one. So for my next one, I think I will go over... I'm going to go over my energy restoration. C++ class, because much like the lock-on actor, it also has a mixture of C++ and blueprints as well. So this one's pretty standard and straightforward. I haven't done anything for an interaction command on this, as I haven't found any particular sequence that I want to do yet. It's pretty basic, straightforward. Just your standard on collision, your binding events, such as from last time. Basically, when they walk in, what I do is I check to make sure it's the player that's interacted with it. I get the original amount of energy reference from the player, and then I change the material on the player. That's kind of how I got that kind of glowing effect. I'll go over that after this. And then so just like my in my parent class, I have a method that I like to use a timer handle on. So in this case, instead of moving the object or anything like that. What I do is I'm actually lerping the amount of energy on the bar from where it is to the maximum amount of energy, which I can demonstrate here real quick. So what happens is, give me a brief moment to expend some energy real quick and get this going. So expend a little bit there, a little bit there, a little bit there. Kind of a nice little glow effect. I like to call it my glow stick Dr. Manhattan. I think I've already made that joke previously in this video, but it's alright. So what'll happen is, like I said, once I get into the fog itself, I slowly begin to, well, it's kind of quick in this case, but it went from generally the lessened amount it was to a full energy restoration. So that's something I plan on using to allow the player to restore their energy at various points throughout the level. I do plan on letting the bar actually be self-regenerating at a later point in time, but it will be more often a slowed regeneration, such as to make this class not useless. So, as far as this class is concerned, so this guy goes into some new stuff that I had done for my player. So from changing my player material, actually that's specifically on the player blueprint itself, in which case all I'm simply doing is I'm actually using a method called alter material, and one of the inputs is actually a materialed instance. And so what I essentially do is I take the input instance and then I set both material indices for the mesh, which can be displayed here, and I set them to a specific instance. Pretty straightforward, pretty standard. I'm going to kind of go ahead and go through that material. Yeah, so here I'm going to go ahead and kind of go over my material itself. It's pretty standard and straightforward. I wanted to kind of give like a glowing mesh type visual for this. I did end up finding like some research on like some different nodes that might have been good for that. I found one that kind of helped make an outline on a mesh, but that wasn't quite what I was going for when applying it to the character itself. But what I found that I was able to do is that by making two parameters here, power and reflection, I was actually able to control the outline and glowing of the actual material itself. So for instance, before had I set this to so for this one, what it does is it just basically kind of puts a baseline of refraction of light from the material. This controls like the refraction of the, or actually the emissive glow, so to speak, of the material. And then the power is what helps me range how much of the coloration it is for it. So for instance, say I put this on like 2. You'll see that like the actual glow itself has kind of like disappeared now, so to speak. So if I take this and I put this to like 0.05, you'll see that what's happening is like I have sort of this bluish outline around what is around the normal character color. And so what this generally did for a mesh is that it would basically just have like this very, very light emission outline for the mesh itself, which wasn't really what I was going for. But through playing around with it, I found that if I actually inversed this power for the exponential in, what it does is it actually reverses the way the emission works with the coloring. So instead of creating a glowing emission on the outline created by this reflection variable, I'm actually going on all the space that is not occupied by the reflection variable, thus creating, thus taking all the colored space of my normal color and actually replacing it with a bright light emission fusion of a glow color and then the standard refractional light color that comes from this reflection mechanism, parameter, I should say. So I hook all this into emissive color, and that's what allows me to get that kind of like glow effect, which I can kind of demonstrate here. Or actually, it's already being demonstrated because it's on, because I use the same material on my animation for the skeleton. So as you can see here, it kind of doubles as both recoloring my my character, but also adding like kind of a glowing emission to them as well. So that's the kind of visual that I was going for this. Yes, next. So the next thing I kind of want to go to that is both a combination um, of my C++ and my my blueprints would be my grindable rail that is found here in level. So as I said, I did have this somewhat worked on from a previous video. However, it did need some polish and also some bug fixing as well. So give me a moment to open the blueprint editor, and I'll kind of start with that because this portion is very important to understanding to how this works from a designer standpoint. So something that I do here is I make use of what Unreal refers to as a spline component. And a spline is kind of a twisty, bendable, editable mesh that works as a series of points. This is very commonly used in things such as like automated racetracks and things such as that. It allows you to create bendable meshes in game without having to without having to go to some kind of art software or perhaps ask one of your artist friends to manipulate the mesh for you. So basically, to save some of the trouble, because there's quite a bit to unpack in this, I'm going to go ahead and kind of go over the highlights for this. So essentially what this does is this actually takes individual spline meshes, and what it does is it kind of like essentially hooks them together into like an array of spline meshes, shown here by my variable our spline points, is essentially a long array of spline components that are all connected together. And what I'm essentially doing is, and I'll demonstrate it here in level in a second, is that I'm creating a new spline mesh segment. I'm setting it to the parent static mesh. I'm setting what is considered the forward axis. This is important for the C++ that I'll be demonstrating here in a minute. I set the collision for it, so that way this is what allows me to have my capsule collider interact and allows me to begin the grinding. And then here in the final node, this is the set start and end, to where I'm able to essentially glue the segments together. It has a couple inputs as well, including my location for them along the spline, things such as that. It basically finds the endpoints and kind of glues them together is essentially what it does. So I can kind of show you what it is that I'm talking about when I go all the way up here. So, or actually I'll kind of show you along here. So as you'll notice, because I have it clicked, you'll see that there's the metal rail itself, and it's bending and twisting that's weird malformed shape that I had earlier. But you can also see that it's kind of like a series of points with these little white squares. This is actually the result of the blueprints itself, is that every time I create a segment, it creates a new end and marks it with a white square. And what I can do is I can go to one of these ends. I'll start with the one right here, and what I could do is I can alt-click and essentially create a brand new point and then kind of bend it and twist it the way that I want. So I can rotate it, have all that fun stuff. There are times where it can potentially be a little bit slow to kind of do some of the twist and bend updates, as I do generally do this on construct, so things like that can happen. There are a couple of variables involved including the total length of your spline, how many of these points you actually have, the mesh that you're using, because not all meshes really have a good way of bending. I got lucky that in Unreal's starter content there was a nice little door individual side door frame that I was able to use to kind of act as a rail, so to speak. But essentially what happens with this, going back to the C++ side, specifically for when my character interacts with it, is I go over to my collision, and what essentially happens is if I detect that it is a form of spline component, what I do is I cast the grindable rail, or no, sorry, I get a reference to my rail itself, um, and what I do is I set is grinding to true. That's what lets it know to begin for the grind sequence. I get the amount of time to grind, which is actually uh, in my grinding class as well, my grindable rail class. That's the number of seconds that I should spend going from the beginning beginning to the end of the rail. Um, I made it this way so that way I could have kind of an adjustable speed because I figured my rails would probably be of varying lengths. So that was, for right now, the best indicator of speed that I could do. So if I go down here to... So I go to begin grinding. I use another timer handle just because I like using timer handles. They're a great way to run code repeatedly without using update. So that's very nice. So what I essentially do is I turn off my gravity scale to 0. I disable the camera, so that way they just kind of the player doesn't have a free range of the camera, and having it update with the rotation of the spline itself. So essentially what I do is I find my distance for on contact. Generally what I do is I am able to get my spline to where if I jump on the spline at any point, it will start right there and then beginning only from that point to the end. So that part's pretty good. So I get my location at distance along spline. These are a lot of spline-based pre-built methods that allow me to move it along the spline itself. So I use my my timer handle, go through grind, and I go at a rate of delta seconds. So this is the method that actually is responsible for moving me along the rail itself. And this section right here is kind of what determines the speed. So I go from a range of 0 to 1 because I use the lerping method to transition myself across the spline. In order to control it in a sort of in a speed-based manner, what I do is I divide the number of delta seconds being added to the total distance uh, to my distance float, representing from 0 to 1 how far along the spline I am, by the amount of time to grind, thus simulating the amount of seconds necessary to go from beginning to end of the rail. Once the distance is actually hit a full brink of 1, what I do is I'll get through here, turn my gravity back on, clear my timer, and I generally give the character a little bit of a launch, kind of keep the player off the rail, so to speak. Set my camera control back up, and then and then obviously turn my is grinding back to false. That way I'm able to get back onto a different rail or maybe the same rail and then just go grinding from there. I'll use specifically only main HUD as this functionality is kind of shared between my different menus. So for my menus with that green highlight that you saw earlier in the video, is made by this functionality right here. So what I essentially do is I make an array out of all of my interactable buttons, and I check to see if they're hovered or if they have user focus. If either of these is true, what I'll do is I'll set the color and opacity of the button itself to this green color, and if not, it's just the standard color button that was on the UI. Pretty simple and straightforward. So when it comes to here, what I basically do is once the player interacts with the sphere that is located around the center of the pedestal here, what I essentially do is I remove the UI reference, Set the character's current state to stun, that way the player doesn't move after they've completed the level. Um, then I will do my camera transition using set view target with blend. To blend it from the character controller to my to this actor itself, specifically the camera attached to the actor that you see right here. Seen in this similar view right here. Um, then after that, I simply do a delay so that way I can do the full camera transition. Then I create my widget of level completes and then add it to the viewport. So this right here is my widget for my level complete. I kind of wanted to make something that reminded me of the Sonic the Hedgehog, um, or something similar to Sonic the Hedgehog, where at the end you see your different stats that grade you on your performance of running through the level, and then gives you your overall score. Um, yes, so there's quite a few functions to go through here for this one, as I am mostly I'm doing a combination of animation plus simulating animation for this one. My only real actual animation, as I'll demonstrate here, just simply moves these individual UI elements onto the board itself. They don't actually do any of the score display or filling of the bars. That's actually done via code in Blueprint, which I will go ahead and show right here. So this is my overall wrapping method for filling the bars and then going through all the values. I use a timer handle, same as I use for a lot of my LARPing in-game. So what I do is I have my... Nope, not there. There we go. So I use my timer method to essentially what I do is I'll go through here. I have my float for the timer count. What I'll essentially do is I will, using my timer handle, this will be called, and I check to make sure that it's from a range of 0 to 1. And so what I do is I essentially, as long as it's less than 1, it goes through all of these individual methods right here, which is each responsible for a different part of the board itself. So this method right here simply sets the values for each of for the progress bar, the text inside for the percentage, and then the text for the actual score itself. All of this I wrapped into one convenient method, so it gets the count from the UI, the max value from the UI. Using time count is how I actually go from 0 to max value for all of these. Things like that. So I set the percentage, then after that I set I do set text for the percentage inside the bar, and then I do this for the actual score. I generally round as I keep, as I lerp using a float because you cannot lerp an int. So what I generally do is I cast it to a float, and then I lerp it, and then as it's being lerped it gets rounded back into an int, and that's how I'm doing the action of progressively showing the score increase. This is true for let me go back to the designer. So I use a similar method for each of these for time fragments, time ability shards, time completed, and bonus, as well as the grand total that is displayed here. Which I can show you that they are all quite similar. Again, same thing here, get the UI reference, lerp, more lerping in order to show the score increasing. Same goes for the time, the bonus score, and things such as that. Once it gets through to the end, displays the grand total, and then yeah, that is the end of it. So that pretty much wraps up all the work that I've done here for this particular 2 weeks. Look forward to my next video, and thank you for watching.